Okay, question 2. Oxygen is an odorless, colourless gas that is present in the Earth's atmosphere. Fairly good. Good thing too. A. Draw a diagram showing all the outer electrons to represent a molecule of oxygen O2. All the outer electrons, now get that, all the outer electrons, you don't need to put the inner electrons in, to represent a molecule of oxygen O2. So there's a couple of traps here. One is you just draw the atom for oxygen, and that's not what they're asking you to do. They're asking you to draw the covalent bonding of two atoms of oxygen joined together to make the O2 molecule. Okay, so what we can do is we'll represent our nucleus with the chemical symbol, which is O. And then what we'll do is we will draw two intersecting electron orbits. And what we have to do here is we have to remember that oxygen has the atomic number of 8, which means there's 2 electrons in its inner shell and 6 electrons in the outer shell. And that means that if we're going to remember that this one, if we're going to count, we've got our 1, 2 in the inner shell, and then we have 3, 4, 5, 6, 7, 8. Now, the point is that these electrons here are used for bonding, and the paired up electrons don't bond. And if we do the same thing on the other side, we'll just represent the electrons with O's. The important thing is that you can do this, you can either have them on the lines here, but they show that they're being shared, so they're inside this area here, or you can put them inside. If I just did them like that, you can do it like that. And there is another way to represent this if you use an electron dot diagram, but you don't have to. You can do this. So remember that oxygen is 1, 2, 3, 4, 5, 6, and then these 2 electrons are used for bonding. So we would represent that by doing 2 oxygen atoms next to each other. We've got our unshared pairs at the angles. It's a bit hard to do with crosses, actually. And then in here we have X, 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 and that's our bond there. That's our bond between the 2 atoms. So that's allowed. You can also do this with these X's as O's to represent that the electrons come from this atom rather than this atom. Technically, this is only used for illustration purposes for covalent bonding. It's wrong to use different symbols for the electrons because the electrons are the same thing in both atoms. But anyway, name an element that has similar chemical properties to oxygen. Well, what you want to do there is you want to go to the the data book and find an element that's in the same group as oxygen, and the best one to use here is sulfur, which is the next element down in its group. Okay, that's simple. Remember, the groups are the elements with the same chemical properties. So we've got the alkali metals, we've got the halogens, we've got the noble gases. Oxygen, whatever element is underneath oxygen in the periodic table will work for this, and that's going to be sulfur in this case. Graph shows the solubility of a compound containing oxygen at different temperatures. Here's the solubility, here's the temperature. And it says, state the relationship between temperature and the solubility of the compound. Basically, all you're being asked to do is be able to state a relationship. So remember, we have our basic method of doing this, which is as the independent variable either increases or decreases, so the dependent variable either increases or decreases. So we're just going to say that. So as, okay, what's our independent variable? Is temperature. And what's it doing in the graph? It's increasing as temperature increases. The solubility, the oxygen solubility, it decreases. As the temperature increases, the oxygen solubility decreases. Okay, that's the relationship, and that's all you have to write. As the temperature increases, the oxygen solubility decreases. Good. Let's move on to the next part of the question. Here we go. Oxygen can react with fluorine to form oxygen fluoride molecules containing covalent bonds. Molecule of oxygen fluoride is shown. There it is there. State the name used to describe the shape of an oxygen fluoride molecule. Right. Well, the correct answer, according to the marking scheme, is angular, because it's not straight. But the other one here is that you could use is bent, which is perfectly reasonable in chemistry thing to say, but it wasn't included in the marking instructions, so I'm not quite sure about that one. I'm sure bent is perfectly acceptable. In fact, that's the preferred naming in quite a lot of chemical laboratories. So anyway, there you go. Circle the correct words to complete the sentence. A covalent bond forms when two positive, negative, neutral nuclei are held together. Covalent bond forms when two positive nuclei are held together by their common attraction for a shared pair of electrons. Well, the nuclei have to be positive, right? Because nuclei are always positive, so we're going to circle positive. Held together by their common attraction for a shared pair of electrons, and the bond is a shared pair of electrons. Okay, so nuclei have to be positive because the only thing in the nuclei are protons and neutrons, which gives you an overall positive charge. The shared pair of electrons is what's being shared. The electrons are the thing that's being shared. So there's a definition, if you like, for a covalent bond. A covalent bond forms when two positive nuclei are held together by their common attraction for a shared pair of electrons. So if you want a definition for a covalent bond, you could use that in the future if you're ever asked for one. So there you go. That's a nice, neat one. And this is obviously an SQA approved definition of a covalent bond. There you go. That's the end of question 2. See you next time.